This is problem 7-77 from section 7.1.5 homework. Your scientific or graphing calculator can function in both degrees and radians. See if you can determine how to put your calculator in radian mode, and then how to switch it back to degree mode. On most scientific calculators, a small degree or radian shows on the screen to let you know which mode you're working. Part A. With your calculator in degree mode, find the sine of 60 degrees and record your answer. Then switch to radian mode and find sine of pi over 3. Did you get the same answer? Explain why your answers should be the same or different. So we're going to start with part A and get to part B. So on our calculator, we have been focusing on degrees, and we've had to change it from radians to degrees, possibly, if we were having some errors. So I hit mode button, and to change it back from radians to degrees, I'm going to highlight radian or highlight degree. So for this case, we're just going to keep it in degrees first, and we'll go back and change it. So we're finding the sine of 60. So sine of 60 degrees equals, I get 0.86, about 0.87. So I have, for part A, sine of 60 equals, we'll say, 0.87. Okay, so it says change it into radian mode and find the sine of pi over 3. So we hit mode, and now we need to be in radians. So we're going to hit enter until that's highlighted. Quit out of that. So now I am in radians. Sine of pi over 3 equals 0.8. The same result. So let's record that over here. Sine of pi over 3. Now I'm in radians. Radians are always going to have pi's in the expression. So that's how I can know the difference between radians and degrees. If it's radians, it'll always say pi something. Okay? So explain why your answers should be the same or different. Well, what's really happening is if I have a circle here, let's draw a little circle, and we have 60 degrees. So I'm starting from this right part, 60 degrees, maybe that's like this. Okay? 60 degrees. What we found the other day is pi over 3 is the same measurement. Okay? This is also pi over 3. Since they're the same measurement, they should have the same vertical distance, right? That's what sine is. So I could also see, if I'm not sure that those are the same, if I just split this top half into thirds, approximately here, right? I know 180 degrees, this is pi radians over here. So if I split it into thirds, I just want 1/3 of that, so I know this really does equal 60 degrees. So since they're the same angle, I should get the same height right here. So we really were finding the sine of that, so that's the height, vertical height. Part B says find the sine of pi over 4. So again, that's still in radians. So sine of pi over 4. We're going to make sure we're still in radians on our calculator. Now, unfortunately, on the graphing calculator, there's not really a way to tell if you're in radians or not besides hitting the mode button. So we're going to do sine of pi over 4. We're not going to use 3.14 for pi. We're going to use the exact amount of pi. So pi 0.707. So we'll maybe keep that to 0.71. Okay, equals 0.71. Let's see what the rest of the question asks us to do. So we found sine of pi over 4. Which angles measured in degrees would have the same sine as pi over 4? Well, let's first figure out what is this measurement in degrees. So pi over 4, again I'm going to use my little circle as an example. So here's about 0 degrees right there. If I split this in half, I know this is 180 degrees, but in radians it's pi. So let's just split these into fourths. So 180 into fourths. I know each of these is going to be worth 45 degrees. So since I know 45 degrees is the same as pi over 4 radians, now I can find my other angles that would be equivalent to 45 degrees. Okay? So the way that we did that was kind of with our reference angles. So 45 is already one of the answers for the degrees. Now what we want to do is we want to talk in the second quadrant somewhere. What value is this going to be? Okay, so I can take 180 minus 45 to get my right quadrant value. Okay, so that'll be 135 degrees. That's another value that's the same amount per sine. If I want to go in the bottom left, which is quadrant 3, I'm going to take 180 degrees plus my reference angle, because I went all halfway around and a little bit more, so this would be 225 degrees. And if I want to find in the fourth quadrant, I'm going to say 360. That would be if I went all the way around the circle, but I didn't quite go that much. I went 45 degrees less than that, so 360 minus 45 will be 315. So those are my equivalent angles to pi over 4, but they're just in degrees. Okay? So make sure if you're given in radians, there should be pi's in your expression. So radians, this is in